Thank you for having me here today. I'm always excited about presenting bolt threads to a new audience. This is a project I've been working on, including graduate school, for about 13-ish years now. So it's been a big passion project of mine. And over that 13 years, I've actually learned something that I find quite astounding. I've become fascinated by the clothes we wear. It's one of these places where every person on the planet uses that product. But it's something we never think about, and we certainly don't think about it as technology, when in fact it was the heart of the Industrial Revolution. But we'll take this story back, and we'll start somewhere very different. So this is me. This is my 5th birthday. I remember it very vividly, and I'll explain why in just a second. But you could look at those, that goofy haircut, the giant ears, the nerd glasses, and this convinces me each time I see it that I was born a nerd. And it was at this birthday, my 5th birthday, that really cemented it when my parents, a biochemist and a pharmacist, gave me this birthday present. A compound microscope was the right answer for 5th birthday. So what 5-year-old needs this? Nobody. It's kind of you'd think of it kind of as a dud of a birthday gift. But in reality, this changed my life. Most 5-year-olds watch TV and listen to music and do those things. I was out with my friends digging up dirt, scooping up pond water, and doing all sorts of fun things that opened my eyes to the power of the natural world around us and to asking good questions and seeking answers. And so this shouldn't surprise you then when I tell you that I went on to become a scientist. I did a PhD in chemistry and chemical biology at UCSF, and really the focus of my work there was on synthetic biology. And synthetic biology is this idea of using the tools and techniques that nature has provided for us to build consumer products for the future. And in particular, I became fascinated with the materials around us, including the silk that spiders make. And when you think about the tools of biology, it's this really powerful technology. It's self-replicating, it self-repairs, and over time it adapts to the environment around it. So it creates new features. Maybe over long time scales, but it's doing that. And we've had life on this planet for 4 billion years, using evolution to create new materials and new features. And so I started this company, Bolt Threads, with this idea. Take the materials from nature and apply these new tools and techniques from synthetic biology to be able to create the materials for consumers of the future. Now, when I think about consumer products and all the things we wear, we talked a little bit, mentioned clothing in the beginning. One astounding thing is that there's a very limited palette of materials to work from to make the fabrics you use every day. And this is a picture of a scanning electron micrograph of some of the common fiber types. There's a couple missing, but there's not a lot missing from this graph. You're really limited in what you have to choose to work from, and this has been true for us for about 5,000 years. The most recent entrant is polyester. Now, the interesting thing I see about this, though, is that this small palette of materials drives a gigantic consumer market that makes 80 billion garments a year on this planet, and that all of us participate in. It measures trillions of dollars, as I'll point out later. The other thing is that there's actually a rich history of innovation driving differentiation and margin in this space. And this surprised me when I make this graph. Every time I see it, it actually does stretch back 200 years. Whether it's the Industrial Revolution and inventing things like better ways to knit and weave fabrics, or the modern miracle of the 20th century using petroleum to make high-performance fibers. It really started with nylon, by far the most important invention on this slide, in 1935, but has continued for about the next 50 years. And then we reach a very interesting date, 1971 on this slide. Interestingly, nothing major in polymer science and fibers for the things we wear has really emerged in the last 50 years. And I'd argue that we ran out of things we could make from the way we use petroleum as a precursor. And that's where Bolt Threads comes in. Now, over that time, we also realized that petroleum comes with a big problem. Bunch of things that come up, but in particular, the longevity of the polymers. You have to look no further than our oceans, and apologies, I got cut off here. That number is 2050, where you expect more plastic in the ocean than fish by weight. But that's pretty bad. That's kind of a big impedance mismatch between what we're trying to use a product for and how long the materials last for. And this is actually not even the worst part. This is only the part you can see. So this is a fleece jacket. I'd be shocked if none of you know what this is. You probably all own one. It's fleece, polyester fleece pile. Use it to stay warm when you're out there and it's cold. This jacket has a massive problem every time you wash it. Every time you wash it, about 100,000 to a million polyester microfibers that are microns in length go down the washing machine drain and into the ocean. And they look something like this. And that's not even the worst part. These fibers get eaten by organisms in those ecosystems that move up the food chain and into the fish that we eat on our table. There was actually a good article in the San Francisco Chronicle not too long ago looking at this in the Bay Area. And humans are eating an increasing amount of plastic in our diets from the fish we eat. This is a new problem. We just kind of figured out this is happening. We don't know if this is good, probably not, bad, who knows, or catastrophic. But it's a problem. And those fibers have about a 200-year half-life out in the wild. So for a piece of apparel you're going to wear for 1 season, 2 seasons, be a hero and wear it 10 years, half-life of 200 years. Now, it sounds like a big problem that's hard to solve because this is global in nature. But there's a bright light here at the end of the tunnel. This is a giant marketplace, around $4 trillion, and consumers love to consume. So when a better material and a better process comes along, there's a voracious appetite and a rapid uptake of new products and technologies. So we think there's a big opportunity here. And so when I look around, I think the solution has actually been in front of us to solve this problem for longer than humans have been on this planet. And I think it comes from the silk of a spider. So this video right here, this is called the Darwin bark spider in Madagascar. She's spinning these fine, elegant protein fibers out of her abdomen. And those are a protein filament we call spider silk. And they're soft, they're hypoallergenic, they're completely biodegradable. She eats moths and bumblebees and things like that to make them. But they're stronger than steel by weight, and they're 6 times tougher than Kevlar. So this amazing material that far exceeds anything we've ever invented from petroleum science has been there for hundreds of millions of years. And in fact, that gets even better than that. You look around the planet, and we have almost 4 billion years of evolution creating new features and functionalities all over the place, really beyond just making fibers. So I'll just point out 2 here rather than take up all this time talking about all 6 of these. But you think of something like a barnacle. Most common feature is it's stuck to everything. A rock, a ship hull, a pier. It's making a glue that can cure itself within salt water and is made from a protein. Or take this guy in the middle here. I don't have a pointer, but this says absorbent. That's nature's ugliest creature. It's called the hagfish. The hagfish makes a slime that it uses to neutralize prey from biting it that absorbs about 1,000 to 10,000 times its weight in water. Imagine a diaper that's paper thin for your kids that never leaks. And the list goes on and on. This is just the tip of the iceberg of what can be out there over 4 billion years of evolution. So we look at spiders, as I said before, and spiders are amazing in that they make this amazing silk. They have one obvious problem, that you can't collect the silk from nature. The obvious thing is to take the spiders and farm them. And that's kind of what we're doing here. This is actually our first office in San Francisco with a bunch of free-range Nepheloclevipes. They're about teacup saucer size in diameter. These guys actually, they're all female. They eat each other when you leave them overnight. That's a problem. Cannibalistic is not going to make a farming technique. And they also make very little silk per spider. So it leaves me with the obvious question. How do you make this amazing fiber without that pesky spider there? And so that's what Bolt Threads has done, and here's how we do it. This will be in very simplified format. So if you're a biotechnologist, apologies. If you're not, hopefully I can get you on board here. So we look out in the world, and when nature evolves a new material, it stores the information for how to make it in the genetic code of that organism. So what we'll do is we'll go and we'll look at DNA from the world around us, at natural sequences, bring them in, and then have our smart scientists in the wet lab, like Thomas here, go through and figure out how to readapt that to work in a scalable organism. I say scalable organism, that usually means single cell. We use yeast. Yeast is a really impressive organism because it already works at global scale biotechnology. Anyone who's had beer, wine, bread, you've used a product of biotechnology, and it works all over the world. So Thomas will go in here, take that information from nature, tune it up, get it working in yeast, and gets it working at essentially that microtiter plate scale on the, I think it would be on your right there. Unfortunately, that's not enough material to really do anything with. You're talking about milligrams or micrograms. And so we turned to another yeast-centric technology in fermentation. So this is taking ever larger vessels, big tanks, stainless steel like this 200-liter that Toby's operating here in our pilot plant, and grow these yeast in ever-increasing scale where they mass-produce the spider silk and secrete it outside the cells. We'll then purify it, and it looks something like a whey protein, something you'd buy at a health food store for after your workout, drink a protein shake, except for instead of being a simple whey protein, it's recombinant spider silk. Then we take that as a polymer precursor and go into fiber extrusion. So on the left here, I've cut out the middle of the spin line. It's about 50 feet long. On the left, what you see is off the picture at the top is liquid silk. That's being extruded through a die. We call it a spinneret or a spin pack. And you're seeing 50 fine filaments. That white filament there is spider silk spun without spiders being extruded. And then the little video is just, it looks kind of boring, but it's actually quite exciting. That's spider silk grown in a tank, being wound up in color at the end of the process. And so what's quite exciting about this is now you've got a process that you can engineer from idea and genomic information all the way through to material properties. And it actually gets a lot better yet. When nature evolves a new material, it does it in a very Rube Goldberg way in order to select for function, not for perfection. So if you think about spider silk as this series of colored dots at the top of the slide here, we can go in and kind of remove some of the cruft over time and tune for things that are already there, like strength or stretch. And then it gets a little wilder. We can go out and look at nature for features and functionalities that have evolved independent from silk, things like UV resistance or water repellents. Bring that information out. A smart scientist like Thomas, like I showed you before, will put that together and make chimeric silks that have never existed before in nature because nature didn't need them. But we as consumers could replace these plastics in our lives with things that are higher performance and higher sustainability. And this opens a whole new paradigm for how we do materials development. I would argue that in the past, scientists would discover materials and then hope to find what they're useful for, hammer searching for nails. Now we get to do something where we know what the marketplace wants, we know what nature has shown is possible, and Bolt Threads has built the platform to bring these things together and make it possible to take only what you know works to market. And so I've shown you a lot of things at small scale. Let's talk about what we've done over the last few years, just briefly. We've been really focused on scaling up this technology, which is one of the hardest parts of biotech. This is a picture of a factory we built in Emeryville, California. This is a big version of a spin line that does about 10 tons per year worth of fiber at a very high rate and room to expand. And we used that to launch the very first commercial biotech product made from spider silk ever earlier this year in March. We did a one-of-a-kind, limited edition spider silk tie. I'm actually wearing one today. And the idea here was to show that after 50 years of people chasing this technology, that we're now in the point of reality, that things are working, and that we're going to be delivering consumer products at an ever-increasing pace and volume. We've also partnered with some great folks. Patagonia, probably know them, outdoor lifestyle company, tremendous commitment to both performance and sustainability. Best Made Company, who you may not have heard about, but we acquired them back in July, it was announced. And one thing, I'll just do a small aside on Best Made. When you're building these technology companies, I think it's always best to understand your customers' problems as much or more than they do. And it was advice I got very early on. And we've actually manifested that into reality by having a brand where we can take product all the way from start to the consumer's doorstep and measure that feedback and put it back into the technology loop. And that's something that should not go underestimated. We've also been in a partnership that we announced recently with Stella McCartney, and I'll go a little bit more into detail here. Stella runs a tremendous fashion brand focused on fashion meets sustainability. And she walked through our labs a little while ago when we were working on this partnership and was just blown away that technology was coming to an industry that has not seen any new technology since the electric motor automating the sewing machine or the loom. or maybe even nylon in 1935. But really, the idea that we get to work together, and she's made beautiful things from these materials that we've put together. So we actually put this piece, it's a gold dress. It was commissioned by MoMA in New York. You can actually go to this, I think it's Fashion Items is Fashion Modern, and see this there as part of the exhibit. And then we did this, the two brown pieces, the bodysuit at the top and the parachute pant, were actually displayed here about 2 weeks ago at Paris Fashion Week during Stella's show. And we're just absolutely amazing place to debut these. And this is just the beginning. We're going to see a lot more coming over time. I think great startups take their technology, finalize it, bring it to market, and do it in an ever-increasing scope and scale over time. And that's what we're going to be doing at Bolt Threads. Thank you for your attention today.